I am, my name is Jonas. I am here to walk you through a project I recently completed as an Apziva resident. The project titled Intelligent Product Marketing Strategy using Machine Learning. This project aims to use an European banking institution product marketing campaign data set generated from their call center to predict product subscribers, improve the efficiency of a previously random search for product subscribers, identify customers mostly likely to subscribe, and segment customers to identify subscribers attributes and optimize marketing of additional investment products. So this project was done using Python programming language. So I imported the libraries here and loaded the data set. This is first five rows. Each column include age, which is the age of the customer, job, the job type of the customer, marital, the marital status of the customer, whether the customer has married or not, education level of the customer, default, whether the customer has defaulted for a loan before or not, balance, the account balance of the customer, housing, whether the customer has a housing loan or not, loan, whether the customer has a personal loan or not, contact, the type of contact through which the customer was contacted, the last day the customer was contacted, month, the last month the customer was contacted, duration, the call duration between the customer and the agent, campaign, the number of times the customer was contacted and why, the target variable, which shows whether the customer subscribed or not. So I examined the shape of the data set. So it has 40 rows, 40,000 rows and 14 columns. So I carried out exploratory data analysis to understand the distribution and also process the features for modeling. So during the exploratory data analysis, I examined the distribution of the target variable and visualized it using a histogram and a pie chart. Here, the histogram shows the count of the classes, while the pie chart shows the percentage of the classes. So as it can be seen here that the data is highly imbalanced. Out of 40,000 customers that were contacted for the product subscription, only 2,896 customers subscribed, while 37,104 customers did not subscribe. This amounts to 92.8% and 7.2% respectively. So this implies that the company has been calling customers who never going to subscribe. So my main goal here is to develop a machine learning model to increase the efficiency of the random search, which is this, and also to automate the identification of the resubscribers so that unnecessary call will be prevented. So in order to achieve this goal, I developed two levels of model. One, the pre-campaign model, and two, the post-campaign model. So in order to develop the pre-campaign model, I dropped the correlated features, which includes the duration, campaign, month, and contact. I did this to prevent data leakage. So I also did feature engineering, and I also examined the linear relationship among the variables. First, I was examining linear relationship among the categorical variable using Cramer's V. So, and visualize this using a heat map. So in this heat map, it shows that none of the categorical variable is strongly related to each other, but all of them is weakly related to the target variables, which is why, as it can be seen here, that the association ranges from 0.0 to 0.08. So I also examined the linear relationship among the numerical variables. So, and from this heat map, it shows that none of the numerical variables is strongly related to each other, but they are also weakly related to the y, which is the target variable. So they are also weak predictors. So I also examined the linear relationship between the categorical variable and the numerical variables. So from this heat map, is it can see that age group and age is strongly related. So I dropped age column to prevent collinearity because age group contributes more to predicting y, which is 0.08, while that of age column is minus 0.02. So I then did a column by column analysis to process the futures. First, I started with numerical variables. So I examined them for missing values, but none of them had missing values. So I also examined for them for skewness and the presence of outliers. The skewness detected was handled using different methods depending on the level of the skewness and the type of data points. So some of them were handled using log transformation method, while some were handled using Johnson's transformation method. So this transformation was done to prevent the model learning being biased by extreme values. So I also, after the transformation, I normalized the numerical variables using Z-score standardization methods in order to set the data points around the mean and scared using standard deviation. So that's all of the numerical variables will have a comparable scale. So for instance, this is the balance column. So I examined it for statistics, presence of outliers, skewness, and visualize the distribution using box plot and histogram. So this is the script that examine those measures, and this is the result. So from here, it can be seen that the mean is 1,274.277, while the standard deviation is 2,903. So it has its skewness is 8.2592, which means it's a highly skewed data, and it has 4,280 outliers, which amount to 10%, 10.7%. So this is the box plot, and this is the outliers here. As it can be seen beyond the whiskers level, and this is the histogram showing the distribution. So in order to handle this skewness, I examined the maximum and the minimum value. Here, the minimum value is minus 8019, and the maximum value is 10,200 2,127 euros. So because of the negative value here, I cannot use a log transformation method because log minus value is undefined. Unless I add a small value, but I didn't want to add a small value because there is another method that can handle negative values, which is Hugh Johnson's transformation method. So in order to handle the skewness, to reduce the skewness of the data, I applied Hugh Johnson's transformation method. Yeah. So after the application, I examined the statistics to see the effect. So after the application, so the skewness decreased from 8 to 1.0586. So in order to handle the outliers, I applied visualization method here at the limit of 10%. So after that, I examined the statistics again to see the effect of visualization method. So after that, this is the result. As you can be seen here that the outliers now has been reduced to 0. So, and this is the box plot showing the distribution, and this is now the histogram. So after that, I standard normalized it using a Z-score standardization and printed the statistics again to see the effect. So as you can be seen here that the mean is now 0, while the standard deviation is now 1 as expected. So after preprocessing the numerical variables, I also transformed the categorical variables. First, I examined each of them to know if they have missing values, but none of them had missing values. I also examined the unique values, so and printed them. I did this to examine whether they have trailing or leading spaces around them. But as you can be seen here, there's no trailing and leading spaces. So I transformed them using one-hot coding to form dummy variables. So and during the transformation, that is the encoding, I dropped first dummy to prevent dummy trap. So after the transformation of the features, I then understood the distribution and the transformation and this transformation suitable for each features. So I developed a pre-processing pipeline to automate these steps. So here is the pre-processing pipeline script. So after fitting the pipeline, here is the data set. So after fitting the pipeline, the data set could increase from 14 to 24. So after that, I saved the transformed data set for model development. So the next video will be about the model development and discussion of his results.